You may think you've seen this before, and granted, it does look pretty similar to my old VNA, but looks can be deceiving. Return viewers to the channel may notice a change in scenery. There's no way I could do this on my overcrowded bench, so we're in the secret annex right now, complete with a fancy folding table covered in moving mat. So why are we here? Well, like I said, looks can be deceiving, and this is not, in fact, my HP 8712. I sold that to a friend up in Canada, and I'm pretty sure having to deliver that is one of the main reasons that Canada Post went on strike. No, this is an HP 8714 VNA. And not only that, it's an 8714C. Now that may seem like just a difference of 2 letters and 2 numbers, but there's actually a lot of improvements over the 8712, and it's one of the main reasons I picked this thing up. That, and like everything else I seem to buy these days, I got it for a screaming deal on eBay. So what are some of those differences? Well, for one, you get an extra 1.7 gigahertz. The top end of this thing is 3 gig as opposed to 1.3 gig on the 8712. It's also at least 5 or 6 years newer and comes with a decent amount of firmware enhancements. But the 2 major enhancements I want to showcase are actually on the back, so let's go ahead and flip this thing around. Allow me to draw your attention to 2 very interesting connections that were not present on my old VNA, namely LAN ether twist and color VGA video out. Now, those may not seem like a huge deal, but for a mid-90s VNA, those were big ticket items. And that LAN Ethernet connection will be especially handy for screen captures, no more second camera pointed at the CRT. But the meat and potatoes of this video, and you know this because you clicked on the thumbnail, is this VGA output. My old VNA had a weird proprietary monochrome video output that required a $200 converter to get to work with any modern monitor. But this is just your standard VGA output that any monitor from the 2000s onward should support with no issues. While we're back here, I'd also like to draw your attention to the personalized curves of the rear panel. Now these were a custom job that I'm pretty sure UPS charges extra for. So having a VGA monitor connection is already cool by itself, but it opens up an even cooler opportunity. One more time. What if we take this old CRT and give it a bit of an upgrade? Now, I know there's something to be said for the old school charm of a neon green CRT, but I mean, come on, just look at that. It's got more than one color. In addition to being sharper and a lot higher contrast, the C-Series also puts out native multicolor VGA. So you can actually tell the difference between your markers, your traces, and the background. For me, this modification's a no-brainer, and I can't take credit for the original idea. There's a pretty long-winded thread on the EEV blog forums going over how a bunch of different people have done this conversion. In particular, there's one user who even 3D printed a custom bracket to hold the new LCD in the same mounting holes as the original CRT, even going so far as to make a bezel to adapt the curved CRT screen to the new flat panel. And I think that's the route I'm going to go here. The only problem is that user has disappeared, and the STL files that he originally linked are gone. So whatever scheme I come up with here is going to have to be homegrown and a little bit custom. And I think that's going to be fun. Since the original CRT extends all the way back to the back of the case, we should have plenty of room to stuff this small LCD driver and stash the button board for it somewhere in back. Then it's just a matter of adapting the mounting holes on the LCD to the mounting holes for the CRT, and in theory, everything just mounts in and looks beautiful. Why do I feel like that's easier said than done? Pull the center top of the front panel up slightly. Pull the center bottom down, center catches. Oh, okay, it's got clips. More things to break. I wonder if that's why there's this piece of tape on there. Now you see why I can't do this on my bench. Whoa. Whoa. Oh. Ha ha. Huh. Well, that comes off relatively painlessly. The only service manual I could find is missing all of the figures, so this is kind of a guessing game, working off of the just the text and the procedures only. Remove two places. There's two screw 7s. Oh hey, that's a lot easier. Wow. Well, that's slick. The whole thing just comes out. So, this is the display unit. It's a nice big beefy old school green CRT and a real slick shielded enclosure. There's a bunch of circuit cards on the side here, and it looks like this is also where the main power supply lives, and that's going to be handy because my LCD driver board needs a 12 volt supply, so if there's anywhere I can tap that off of, it's going to be inside that power supply. There's two other interfaces. There's a ribbon cable connector at the front and a little D-sub connector here at the back, and that's all she wrote. So the challenge is going to be to make some kind of adapter plate to fit this screen there. Now it shouldn't be too terribly difficult. There's 4 mounting studs right here. The old CRT should just pull right out, and I should be able to 3D print or metal fab some kind of bracket to fit in there. I've actually already got this screen modeled in CAD, so it's just a matter of taking the dimensions off of this screen and cobbling together something that works. Close enough. Now I should probably mention that old CRTs like this typically have some pretty high voltages going on inside, so if you see any exposed wires, don't touch them. I was working on a old Tektronix oscilloscope my freshman year of college at the Purdue Radio Club, and grabbed a hold of the cathode for that CRT and damn near sent me across the room. So, it's serious business. Lucky I wasn't actually hurt from that. Alright, will you just slide out? Ah! Oh. More things to disconnect. This red wire right here, floating off onto the corner of the screen there, that's the one you don't want to touch. So to make this easier on myself, I think I'm just going to rip out this entire driver PCB for the CRT and slide it all out that way, and then I'll have a nice big cavity to shove all those LCD driver components into. Come on, you. There we go. There's that last screw. There we go. All right. One CRT assembly removed. And I am going to try and discharge this thing before I start handling it, so we're going to go ahead and use a very high-tech solution here. I would probably not recommend trying this at home. Okay, that's got to be good. I don't even really need to do that. I'm not planning on disconnecting the anode cable. I'm just trying to make sure there's nothing on this board here that's going to surprise me later when I go to move it. So this is what we're left with. A nice big beefy metal enclosure with plenty of room inside to mount all the different components for my LCD. I do want to try and crack into the power supply on the back here, because in theory I should be able to get 12 volts out of that, and that is exactly what the driver board for my LCD needs. In the meantime, I'm going to go ahead and try and take measurements for the 4 mounting studs on here, so that I've got those for later when I go into CAD. And I can already tell that these calipers are probably not going to be wide enough for that top measurement. Yep, not even close. Now, normally I would just use this as an excuse to go buy a bigger set of calipers, but I'm impatient and I don't want to wait for them to get here. So we're going to go old school and just use this square. It's got centimeters and inches. And I'm going to hope that the designers of this enclosure went to a nice round number and I won't have to do that much figuring. And yeah, wouldn't you know it, it looks like it lines up right at about 205 millimeters. And for the vertical, I'm going to have to look closer at that one. Let's see, my calipers might be big enough for this measurement. Oh, just barely. All right, we'll take an inside measurement and an outside measurement, and then we will average the two, and that should give us our center to center distance. 150.5. That is the very limit of what my calipers can do. That's 155.6, but I don't think it got all the way. Let's give the ruler a shot. I'm going to call that 153. 153 looks pretty close. We'll build a little bit of wiggle into the mounting pattern. Well, on second thought, now that I'm looking at this, there's no easy way to get through from the power supply into the CRT cavity. There's this one little connector up here in the corner, but that's just for the power switch right here. So I think instead what I'm going to do is try and take advantage of this ribbon connector up here, since this already goes over to the main processor board of the VNA. If we're lucky, I should be able to source 12 volts off of that, and if not, I'll have to get even more creative. So I'm not going to be doing a full Fusion 360 tutorial series here, but I want to run over the basics of how I came up with this bracket design. I've had probably close to a decade of experience in Fusion, starting with my freshman year design course, but that doesn't make me anything close to an expert, and I'm sure there's plenty of stuff I could be doing way smarter. The first thing I did was to take the hole pattern dimensions I grabbed from the CRT enclosure and model them as threaded studs. Next, I brought in the model of the new LCD that I made previously. Now this might look complicated, but I was able to make it in about 15 minutes using the dimensional drawing from the datasheet. I threw this on top of the mounting stud pattern, and it quickly became apparent that this was going to be a really tight fit. The next step was to model the VNA's existing plastic bezel as best I could. The dimensions between the mounting holes in this bezel are pretty critical, so I went back to the VNA a few more times to double check some spacings. As all the design constraints got more clear, I was realizing that there was basically going to be no room between the bezel and the LCD, maybe even not enough room, but I charged ahead anyway. I then started sketching out a basic bracket design, using the holes in the studs as my guide, and trying to make the bracket as thick as possible to make sure it would have a fighting chance of holding everything in place. The bracket was going to mount to the back of the new LCD, and I was going to use heat set inserts to mount it. I had about 1.5 millimeters of space between the LCD mounting tabs and its back face, which seemed like enough thickness for the bracket to live in without extending it any further. With any luck, it would hold the LCD securely to the existing CRT studs without adding any additional thickness to the whole assembly. Once I had all the dimensions finalized, it was just a matter of using the LCD reference model and trusting it was accurate. If it wasn't, I could only blame myself, but I'm no stranger to blindly assuming that I've done things correctly, and it only sometimes comes back to bite me. Some small touch-ups and a few more trips to the annex to triple-check some measurements, and the bracket was off to the 3D printer, which I very professionally forgot to set up a time-lapse for. Alright, fairly simple part. It's pretty flimsy, pretty floppy, but it doesn't have to be super rigid in the XY plane. It really only has to hold the monitor in the, well, I guess XY plane, but you know what I mean. Anyway, let's see if it fits the LCD. I don't actually know which side is which. There are 4 orientations it could go in. It's not that. Maybe. Yeah. That's the right one. Ooh, that's a tight fit too. So, we got our 4 mounting holes in the 4 corners. I don't actually know. I think that way is up. Let's see if it mounts in the chassis. Ooh, that's a tight fit. I think I need to make the mounting holes a little bigger. Let's see if that'll stay on there long enough to test fit the front plate. The moment of truth. Does it interfere with the front plate. Oh, it's going to be real close. Nope, I think it locked in. Let's see. Yeah, I think both sides feel nice and firm. Feels like it's mounted flush, and I had no wiggle room whatsoever. That is 100% flush with the LCD assembly. So making a nice little rounded bezel to fit around the outside there is not going to happen. I think I'm going to have to take what I can get there. Maybe I'll mask around the outside with some vinyl just to make it look a little bit prettier. But I think that's pretty darn good, actually. But that fits surprisingly well. And so this is what I was talking about being a tight fit. You can see the four corners of the bezel are basically touching the LCD assembly, so there's not really any room there for any type of fancy 3D printed bezel to mate up properly with the curves. I think I'm fine with that. I think all I'll do is just cut some vinyl or some electrical tape to mask off the metal bezel of the LCD, but otherwise, I'm going to call that good. And that, my friends, is where we will end part 1. I feel like I owe it to my viewers and myself to trim down my videos just a little bit. Making and editing a 35 to 45 minute video every single time was getting a little bit draining and making this whole YouTube thing kind of unfun. So I'm hoping something more like 20 minutes will strike a good balance between informative and too much. That being said, I want to thank you guys so much for watching, and stay tuned for part 2 where we tackle the fun stuff. The electronics.